All right. Over here. Over here, and we're over here. All right. So access memory that we're not supposed to access. So I think I kind of did this in lecture, so there's no point in recording it. So I guess I'll ask people, are you okay with question 1, or do you want to see it? Who wants to see it? Okay. All right. So access memory location that it's not supposed to be accessing, and make it crash, essentially. So, okay. So I'll include std for the malloc. I'm not even going to use the malloc. So I'm going to declare an array of like whatever, 10 integers. And I'm going to print, don't even technically need to print it, but array at like a lot. That is probably going to do it. Okay. All right, and there we are. So that produced the error. So the problem is that we declared an array of size 10, and then we're trying to access element number 1000. That's usually illegal, and that would usually crash. Okay, so we now want to do the thing on Valgrind. So you'll note that when you run the code using the run button, it produces the program automatically. So the program is called lab4. So if you just go to the terminal. So I can try to just run lab4. And that's going to say segmentation fault. So segmentation fault is the memory error in Linux terms. So it asks us, I asked you rather, to run Valgrind on it. And here we have the problem. And it says that the problem is in line 8, which is good because if you didn't know that, or like if you just ran lab4 without Valgrind, it wouldn't tell you like the line number or anything like that. So here it tells you the line number. VS Code also usually lets you know actually like what line is the problem. Not always. It depends on the situation. So it's useful to know about this as well. Okay. So, So we now want to write a program that reads a file that's named a.txt. And we want to see that that produces a memory leak. So we'll do it here as well. So say, okay, so file B is a.txt r. So that by itself is just going to produce an error because there is no file that's named a.txt. So we'll create it in a second. So let's do that. So whatever. I save it as a.txt in lab4. So you'll notice that now it appears here as well. So now if I run this, so this doesn't print anything. It didn't even try to read it. But that by itself will already say that there is a memory leak. So if I do Valgrind again, what you'll see is there was like one alloc, there is 0 freeze, and that's because I opened the file, but they never closed it. So I can fix it by saying close FP. So for now, like I just opened it and that already produced a memory leak. If I close it after opening, that would take care of the memory leak. So as you see, now we're fine. I didn't actually read anything, so but that's a separate issue. So I can read like the first line of it or something. So that says read a line that's at most 200. So I'll create a character array for the line that is definitely going to be contain more than 200. And now I can print the line. So that's just the first line. In kind of the previous lab, you had like a while loop that read all the lines, right? Like this. And that prints the first line. This is the first line over here. So we can check again that Valgrind is running fine. But if we had forgotten the F closed, then that would not be fine. So note that if I don't press run right now, it's still going to be the old version. So that's going to be fine because I didn't actually recompile. I'm running the old program. So if I run it, then as a side effect of running it, it also recompiles. So the next time I run it, that would produce the memory leak. All right. Okay. So this is this. So if open cannot open the file, if open will return null. So now what we want to do is we want to say, okay, like if the file doesn't actually exist, then we want to output an error. So the reason we might like to do it is that if you say something like this, what's going to happen is it's just going to crash. So the reason that crashes is that you are trying to read from a file that doesn't exist. The way you know is FP is just going to be null there. So you would check for that instead of trying to read a file that doesn't read from a file that doesn't actually exist. So you can say, okay, so if is that important? No. So if FP is null, we'll say. Say like cannot read file or something. And then we don't want to do the fgetS. So given that we're not really doing anything, I can just say return 1 over here. So here I neglected to say return 0 before. That doesn't matter by default, it's fine. So ordinarily by convention, if you say return 1 from main, that's an error. That if this is done from main, I did not actually say that in lecture, but that's equivalent to exit 1. So exit 1 is in fact what we have done before in this kind of situation, might as well do it now. you do not need to close FP if it's null because there's nothing to close. It's null. So that is now going to run. That is now going to run fine. Okay, and we can also check that Valgrind is fine, but Valgrind is fine. Okay, so it prints cannot read file, but that's just like, as far as the program is concerned, that's just like output, right? It's not a problem. It's just that the file doesn't exist. All right. All right. So what we want to do now is we want to read a program that's like this. No, sorry, not a program, like data that's like this. So I'll copy this. Save, so I'll save it as data.txt. And we need to like print it. And outputs, so we need to output the sum of all the constants. So like this much plus this much plus this much, right? So several things that we need to do. So we need to extract those guys, and then we need to convert them to doubles. So I guess the first thing that I'll do is I'll convert them to doubles, or like convert like strings to doubles, and then we'll move on to like other stuff, right? So, okay. Uh, so I'll call it my href. And it's going to take a string. And it's going to take a string that definitely contains just a double, and it's going to return the double. So like multiple ways of doing it, but I guess like we'll do it like this. So we are going to read up to the decimal point. So that actually you've done in the previous lab as well. So I'll say, I is 0, and then I'll say while SI is not the decimal point, I'll keep going. And what I'll keep doing is I'll say, okay, so the current digit is SI minus 0. So that gives you the value of the digit, right? Does that make sense? And then, so I'm currently reading like left to right. So if I'm reading a string that's like this, left to right, what I want to do is I want to say, okay, initially I want the result to be 3, and then I want it to be 30 plus 1, and then I want it to be 310 plus 2. And that's going to be the result, right? So the process here is multiply whatever you already have by 10, and then add the current digit. So that's what I'm going to do. So 10 times result, initially that's just like 0, and then plus the current digit. So that's like this. All right. So this is like that. That was up until the decimal point. If you have a thing that's like this, so after you are at the decimal point, and it's like 5, 6, 7, it's kind of the other way, right? So what you want to, so one thing you can do is you can go like from right to left and do the same thing, except with divide by 10. But that would involve going from right to left. So instead, what I'm gonna do is I'm gonna have initially like a factor of 0.1. And then I'm going to say, okay, like result is initially going to be 5 times 0.1. And then the result is going to be whatever it used to be, plus 6 times 0.1 divided by 10. And then it's going to be whatever this is, plus 7 times 0.1 divided by 10 again. So basically, I'm going to divide the factor by 10 every time, and that way I can keep adding to the result. So, okay. I is definitely defined. It's just this is the problem. So here we need I plus plus. So when we are over here, SI has just become the decimal point. So we need to advance I by 1 again. And now we are reading the things that are after the decimal. So, okay. So the factor initially is going to be 0.1. And now we are gonna go until we until the thing is not a digit. So we're gonna say while s at I is greater or equal than the digit 0, and also it's smaller or equal than 9. So there is also a library function, but that's like a way of checking, like, is this a digit? And now we'll just add a factor times the current digit to the result. So the current digit, we also need to compute the same way as before. So you could have an int digit defined outside the whiles, and then you could do it the once. Here we're doing it inside the whiles, so I can do it twice. So that's okay. And now we need to divide the factor by 10. And again, add 1 to I. So that's the whole function. So once we're done with that, we just return the results. Are people finding it? Are people no, this is way too small. Okay. So this is like this. Does that make sense? Yeah.
Sort of do the number check by maybe like saying, because I sort of use like the last character, sorry, like this stop, like the end, like there's like this
Yeah. So you could. The reason I'm not doing it like that is that if you use fgetS, then the last character is not going to be a null, it's going to be the new line character. So I'm just I'm just like trying to make it so that I don't have to strip out the new line character that fgetS gets. Okay, but like what you're saying, like for like the specification of like S is just a string with nothing, that completely makes sense. Okay. All right, so let's just test it to make sure that we're not messing it up. What am I doing? Okay. Cool. All right, are we cool with this? So, okay. So now that we have this helper function, we can read the file and add up the constants. So I'm going to open the file. So this just means I'm reading it. So I'm going to use the code from the lab before. So basically what you're saying is the car line here. We need an initial f get s. And now I'm going to say while line is not null, going to f get s again. So here we got to actually get the constant. From the line. So to get the constant from the line, we got to iterate until we find where the digits start. And then once the digits start, we just send the thing to get constant, right? So I'll say like int I, and I'll say while line I is not equal to the equal sign. So that's like just before the digits start, right? Let's say I plus plus. So at this point, line at I is equal. So that means that I can call my A to F on line plus I plus 1. So that would be the location of the first digit. Does that make sense to everyone? And that's what they return. Okay. So we have the result here. And initially at 0. And we'll add get const to the result here. And we keep doing it after every f get s. So in C, there is actually a way to not do this twice, but we haven't done it in class. So just do it like this. All right. Let's see how that works out for us. There's going to be add up consts, and that's going to be data.txt. That did not work. So I think that's because so fget I believe returns 0 if we are at the end. You're wrong. It's actually a car. Say again?
Is it that there's no return in it?
No, it's that the car. I mean that is also that. So this is car. Okay. So it gets you so it writes the next line from the file to line. So yeah, it also returns it. Yeah. So okay. That's hold on.
Outcast line, there's no other leading line, it will get the no and then.
Yeah. Hold on. Sure, what's going on here? Try to run it one more time like this, and then this is weird. So there is an infinite loop somewhere. That's not actually where I thought it would be. So okay. So put a breakpoint here. Okay. Step into. So the first line is like this. So it's written it fine, so that's fine. I think I actually messed it up. Sorry, Alex. Sorry, I was forgetting how it works. It works like this. Oops. Again, so like this is actually how you check whether you're at the end of the file or not, like the way I did it before. Uh, do not read files in C often. Okay, so that's a different issue. So here we are over here. So we called get const. We called it from add up consts. So the line here is the correct line. So like I mentioned to you before, there is the new line. So we are now here. And the problem is that they did not initialize the I to 0. Actually, I think my previous way might have worked as well in terms of reading, but the new way is better. And now we are over here, and that is all fine. I think that is probably the right answer. So here, one issue is that this guy did not show up. But that is just because when you do printf, it prints with not very many digits by default. So if you tell it, I want 20 digits, you do it like this. This was the link in the handout about how to do it. So that is like, is it the end of the file? So yeah. And because we're doing it like this, we now don't actually have to do it like this. We can just say, it's not the end of the file and just do it. That's going to be fine as well. So I was trying to do it the other way before. So that is it. So there was like a hiccup because I was trying to check whether I'm at the end of the file in a weird way. But I was going to say before, like, how did I manage to write it without errors on the first try, which clearly did not happen. But if it had happened, how would it have happened? Well, because I broke it down into functions, right? So I first wrote my ATOF, and then I tested it, and that actually did work. And then I wrote this, and this had a subtle bug, which I did not catch because by default, I is often 0. And then it became like not initialized, and that's what caused the bug. If I wrote if I tried it with Valgrind, it would have caught it. And then I wrote my add up constants. So here there's a small memory leak because I did not close the file, but if I do close it, then that should get rid of probably all the memory leaks. And if I run Valgrind here, we have actually 3 allocs and 2 frees. So there is something that we did not take into account. So we're calling add up constants with data.txt. We are here, so that is fine. We're opening. Oh, and I returned res before I actually closed, so that was not reached before. So that was the issue. If I rerun it, that is now fine. So there is like junk digits over here, you'll notice. That is just because there is like a finite number of digits in the double in general. So there's going to be junk at the end because things cannot be stored like precisely. Okay. All right. Right. So here we have, okay, so we use the following, so we use the following C code. So we have blah, blah, blah. Okay. So suppose that in Python, we store a string with the name AB and the age 20 as this. Okay. So explain why each of the C function above does not have an equivalent in Python. Okay. So what's happening here is we are changing the contents of a string. That never happens in Python. Right? So strings in Python, there's just like, except if you're doing something weird, there is no way to change the contents of a string. So that doesn't happen. Same issue. Same issue. So here it kind of looks like, at least like this is like a whole string. But what we're doing is we're not like reassigning it. We are saying like, rewrite this to be some other contents, right? So this is the kind of thing that could almost happen in Python, but there would be a subtle difference, right? So the difference would be, so if we are storing it in Python like this, so like AB and then 20, right? And then we are saying change L, and then we're saying like L at 0 is equal to XYZ, right? So that is possible. You call change L, and L at 0 changes to something else, right? So it would look almost the same, but there would be one difference, which is that if you say S is equal to L0, and then you say change L, and then you print S and L at 0, those would now be different. Right? And that's because we're saying, well, like L at 0 used to be something, and then we changed L at 0 to be something else. What we're doing in the C code here is we're saying, write the contents of the name, write something else to the contents of the name. So that would mean that those would actually be the same. So in the equivalent here, so let's say that we have this. I need to change those guys. So I'll create a student 1. And then let's say that I call this guy. So first of all, what's going to happen? Well, the name is now going to be B rather than AB, right? Does that make sense? But unlike in Python, if I save the name, it would be an alias, right? So if I say and then I change the name, and then I also print save name. Those would both print B. The reason those both print B is that what I'm doing here is I'm going to the address as.name, and I'm changing the contents there. So that's the same as going to the address save name and changing the contents, because save name is literally the same address. Okay. I wasn't looking for confirmation from you specifically, but that's good. Okay. It makes sense? Okay. So, all right. So that was like a subtle. Okay. So now write a C function that works the same way as, wait. Oh, okay. So write the function name changes. So we've done that. So now we want to write the C function that does work the same way as the Python function. And the thing that does work the same way as the Python function would be just PS name is equal to B. And unlike change name, write B, that would make it so that the name changes, but save name is the same. It's the problem. PS name. Oh, okay, sorry. That in order for this to work, like we did in class, we actually need to do it with students too. And this would need to be student two. So the reason is, like we said in class, you're not actually allowed to write to an array. So you are allowed to say name is something new, but you're not allowed to reassign the array. So the equivalent would be like this when you're sending student two. The reason this is underlined is I did not change this to student two. And that is now the same. That is kind of a lot. But that's kind of the idea, right? So the way to understand it is, where's my Python file? So the way to understand it is I want to be able to say, like, this component of L is something new. So I just want an equal sign where on the right-hand side is a string, and on the left-hand side is a component of the structure. So I cannot do this with an array. You're just not allowed to say this name is equal to something new. That's just not a thing with arrays, but it is a thing with pointers. If you're looking for an equivalent of something in Python, you always pass the address. So here we're passing the address. You do have to pass the address because if it were that you wrote a C function that just passed the structure, if you change s.name like here, so this is fine because you're changing the contents. But if you're just changing the local s.name, that's just local. the reason this has an effect outside the function is that you are actually going to the address as .name and you're changing the contents there. So that is fine. Make sense? So the wrong thing to do would be to do this. This would just not have an effect. Make sense? And that's just because you're changing